Alright, so this is going to be the rest of section 1.1. Shouldn't be that long of a video. And it is going to illustrate two more ways to find limits. So in general, we can find limits from tracing on graphs. That's probably the easiest way to find any limit. That's why I did it first. And if you're not given a graph, then tracing on a graph isn't much of an option unless you can create a graph. The second thing we can do, and this is usually if I'm not given a graph, is I can make a table to find both a left and a right-hand limit. This is probably the least desirable way. This is slow and sometimes not very, they're not very easy to find a limit from a table unless the limit's a really nice number. So it's not very desirable. But it definitely works. I don't think I could spell desirable, so sorry about that if that's spelled wrong. And the third way we can find limits is using algebra. So this is what we've done so far, and that would be my first choice. So the easiest way to find a limit is just tracing on a graph. That implies that you have a pretty good graph that you can trace on. If I get a graph to find my limit from, then it's probably easier to find a limit using algebra than it is making a table. The next few problems, they ask me to find a limit by making a table and then find that same limit using algebra. And the algebra can go from really easy to really tricky, whereas the tables, they're never very tricky, but sometimes they hide the limit. So question 16 now gives me a name for a function. It calls f of x 2x minus 3. And part 16a wants me to find the limit as x approaches 4 from the left-hand side. We don't have a graph to choose from, so I'm going to do this with a table. And when I see that little minus, that means if I want to find the limit using a table, that I'm going to create a table and I'm going to create a bunch of x values, and each of my x values is going to be a number less than 4. The minus means less than 4, but they're going to progressively get closer to 4. What I'm going to do is fill out the y values for this table, and hopefully the y values are trending towards a specific number, and that will be what the limit is. The unfortunate part about finding limits through a table is there isn't a right or wrong table, and you just kind of go by experience in terms of what values to put in the x's that will point you to what the y's are. So I'm never going to have you create a table on your own. I will always give you the x values and just ask you to fill in the y values, which is what the f of x values are. So because finding limits using tables is not that desirable, I'll just kind of hold your hand through it just so you could see how you can find a limit using a table. So question 16, to find the left-hand limit, the limit as x approaches 4 from the left-hand side of the function 2x minus 3, I can create a table of as many or a few values as I want, but what's going to be important is that each value in my x column or x row is smaller than 4, but they're getting progressively closer to 4. And now I'm going to find the y's by just taking the 3.5 and plug in for that x. So I'm going to go 2 times 3.5 minus 3 to get that y. So I'm going to go 2 parentheses 3.5 minus 3, and I get 4. That's probably not what the limit is, but the limit's probably not really far away from 4. Now I'm going to fill in the next position in my table by going 2 times 3.9 minus 3, just taking that x and making it 3.9. I don't need the parentheses so much. So I'm going to go 2 parentheses 3.9 minus 3, and I get 4.8. Because 3.9 is closer to 4 than 3.5 is, the limit is probably closer to 4.8 than it is 4. Hopefully, as I do these y values, they all kind of hone in or point towards a number that's obvious. So for the third value in my table, I'm going to go 2 parentheses 3.99 minus 3, and I get 4.98. The limit's probably closer to 4.98 than any of the other numbers that I've gotten so far. And the last one I'm going to do 2 times 3.999, which is pretty darn close to 4, but it's smaller than 4, so it should give me a good idea of what the left-hand limit is. When I look at my values, I started off at 4. I was pretty far away from, 3.5 is kind of far away from 4, and then the closer I got to 4, the bigger the y values got, but they didn't get ridiculously big. And if I look at these, to me, it looks like the y values are getting closer to 5. So I'm going to guess that for my answer. Of course, I can put in more. I could have made another spot to my table and did like 3.9999 and looked at its y value. My guess is its y value would be 4.9998 if I had to guess, but I don't want to even try that. So my guess is the left-hand limit is 5. So for my answer, I'm going to write the limit as x approaches 4 from the left-hand side of the function 2x minus 3 is the number 5. Part B wants me to do a right-hand limit. And to do a right-hand limit using a table, I need to plug in my table, in the x column or the x row of my table, numbers that are bigger than that, because plus kind of means bigger, but getting progressively closer. So I started off with x equal to 4.5, which is bigger than 4, and then I did 4.1, which is still bigger than 4 but closer to 4, then 4.01, which is still bigger than 4 but closer to 4, then 4.0001, or 001, which is really close to 4 but not exactly 4. So first value of my table, I'm going to go 2 times 4.5 minus 3. I'll just do that. 2 times 4.5 minus 3, and I get 6. I doubt that that's what the right-hand limit is, but the right-hand limit's probably not that far away from that. Now I'll do 2 times 4.1 minus 3. And I get 5.2. And then I'm going to do 2 times 4.01 minus 3. I get 5.02. And then if this was me, I would be done right now. It looks like the y values are getting closer to 5, and that's likely what my right-hand limit is. But I'll fill in my table because it's not so hard to do. I get 5.002. And again, each one of the numbers in my y column, which is what the f of x column is, they're all bigger than 5, but they're getting closer and closer to 5. So my guess, and that's all you're doing when you're making a table, is you're making an educated guess, is that the limit as x approaches 4 from the right-hand side of the function 2x minus 3 is 5. So I don't have a table for any of the other parts of question 16 because I won't need it. Question C wants me to find the two-sided limit, and to find a two-sided limit, it either doesn't exist if the left and the right-hand limits are different numbers, or it exists and it is what the left and the right-hand limit are. Because the left-hand limit is 5 and the right-hand limit is 5, the two-sided limit is 5. So that's the table approach of finding a limit. So this is make a table. Took me a long time to do it, and you're not 100% sure that this is right because your table isn't, in some sense, ever complete. The way that would probably be best to find this limit, so if I was just asked to find this limit and I didn't have a graph, nor did I want to make tables, well then I could use algebra. And we're going to learn 3 or 4 tricks or 3 or 4 techniques to find the limit using algebra. And always the first thing that I do to try to find a two-sided limit using algebra is just to take the value of x and plug it into the function. And if I get something that's defined, that will be what the limit is. And I'll show you in a bit here what bad things can happen. So the algebra way to find the limit, to do part D, the limit as x approaches 4, the two-sided limit of 2x minus 3, you just get by changing the x to 4 and doing the algebra. So I can say for my answer, the limit as x approaches 4 of the function 2x minus 3 is 5. That's the best scenario. Using algebra to find a limit, if you just plug the number in and you get a value, that value will be what the limit is. So hopefully that's enough for you to do problem 15. Possibly enough for you to do problem 17, but I don't think so. So pause the video, try to do problem 15. If you can do 17, go right ahead and do 17. If you can't do 17, then watch me do problem 18, and that should hopefully inspire you. So again, I'll never have you create a table by yourself. At least I'll have you create the y's but not the x's. So problem 18 wants me to find the limit as x approaches 1 from the left side, part A, of that function. So I'm just going to plug these values in on my calculator. So I'm going to plug 0.5 in for both of those x's. So I'm going to go 0.5 plus 5 over 0.5 plus 2. And I'm going to need parentheses on my calculator. And my calculator is going to give me a decimal. And I'm just going to round that decimal to like 2 decimal places. Maybe 3 decimal places might be good enough. Didn't even need to round it at all. So it gave me 2.2. The limit's likely not 2.2, but it's probably close to that. So for the second one, I'm going to go 0.9 plus 5 over 0.9 plus 2. Again, that's just taking this number, plugging it in for the x's there. I need parentheses. So 0.9 plus 5 divided by 0.9 plus 2. Haha, that's a horrible. I'm going to round that to 2 decimals. I don't have that in the instructions. Should have it in your. So when you do problem 17, round to 2 decimals. Third part, 0.99 plus 5 over 0.99 plus 2. So parentheses 0.99 plus 5 divided by parentheses 0.99 plus 2. And I get 2.00. If I round to 2 decimals, it's 2.00. I'm going to give me that 3 and I'll kick it in there. And then the last one, 0.999 plus 5 over 0.999 plus 2. So 0.999 plus 5 divided by 0.999 plus 2. And I get, again, if I round to 2 decimals, I only have zeros. So now looking at that pattern of numbers, I believe the left-hand limit as x approaches 1 is 2. So my answer to part A is the limit as x approaches 1 from the left-hand side is 2.0. It's just 2, not 2.0 anything. I think that's going to go towards 2. I'll do the same thing for part B. B wants me to find the limit as x approaches 1 from the right-hand side. And so in my table, I plug numbers that are bigger than 1, because plus means bigger, but getting closer to 1. So for these, I'm going to go 1.5 plus 5 over 1.5 plus 2. Then I'm going to do 1.1 plus 5 over 1.1 plus 2. And then 1.01 plus 5 over 1.01 plus 2, and then 1.001 plus 5 over 1.001 plus 2. And then hopefully these kind of lead me to what the answer is. So let me clear out my calculator. So parentheses 1.5 plus 3.5, close my parentheses, divide it by parentheses 1.5 plus 2, and I get 1 point, I'll round that to 2 decimals, so 1.86. Second one, 1.1 plus 5 divided by 1.1 plus 2, and I get 1.97 if I round to 2 decimals. Third one, 1.01 plus 5, close out my parentheses, divide it by 1.01 plus 2. I get 1.997 rounded to 3 decimals. I could have written 2 there, which would have been fine. Again, these probably the tables won't make their way onto a test. I just want to expose you to another way to find a limit if you don't have, I don't know what's going on here. If you don't have a graph. Obviously I messed up there. 1.001 plus 5 divided by 1.0011 plus 2. And this is 1.9997 if I round it 4 decimals. So again, it looks like all those numbers are getting closer and closer to 2. So my answer to part B is the limit as x approaches 1 from the right-hand side of the function x plus 5 over x plus 2 equals to 2. So I did a left-hand limit using a table, a right-hand limit using a table. For part C, this asks me to find the two-sided limit, and because the left and the right-hand limit are 2, that's what the two-sided limit's going to be. So part D wants me to use algebra, and to use algebra to find any limit, my hopes is I could just take the number, plug it in for the x's, and if I could take the number and plug it in for the x's and I get something that's defined, that's what the limit is, and I don't need any tricks. So this is going to be 6 over 3, which is 2, so that's what the limit's going to be. When we go to do the next question, the limit's going to exist, but the algebra is going to be tricky. So the answer to part D is the limit as x approaches 1 of the fraction x plus 5 over x plus 2 is going to be equal to 2. So that hopefully can inspire you to do problem 17. So pause the video and give that a crack. And then 19, the table's not going to be hard, the algebra is going to be tricky, and it's a little premature, the algebra. So pause the video, I'll flip this off. I'll do problem 20. Tables are easy, so I'll do the tables. So A, B, and C aren't going to be tricky. Part D is going to be tricky. So to do the table, the first thing I need to do, the limit as x approaches 4 from the left-hand side, so I take numbers smaller than 4 but getting closer to 4, fill up my table. So the first one's going to be the square root of 3.5 minus 2 over 3.5 minus 4. So on my calculator, parentheses, second and x squared for the square root. Need to close out the parentheses there. And then close out the, so there's the whole numerator. So the square root, the 3.5 has to be in a parentheses, the whole numerator has to be in a parentheses, and then divided by 3.5 minus 4. And I get I'll round that to 0.26. For the next one, it's going to be the square root of 3.9 minus 2 over 3.9 minus 4. Don't want to enter that whole thing again. So what I'm going to do is hit second and enter. And what that does is it brings up the last line that I just entered. And now I can go and I can change that 0.5 to a 0.9 and that 0.5 to a 0.9. So rather than having to type the whole thing in again, what you can do, you can hit second and enter, bring the line up that you just typed in, and you can type over. And so that gives me 0.25. 0.252 if I do 3 decimals. Now I'm going to do the square root of 3.99 minus 2 over 3.99 minus 4. I'm going to try that trick again. I'm going to hit second and enter. And then the unfortunate thing is if I type in 9, then I have to go 9 minus 4. It types over. And that really wasn't that desirable. So for this one, I'm going to go right up to that 9. And I'm going to hit the insert by hitting the second button and the delete key. And then I can type another 9. And that's going to give me 0.250 if I do that way. And then the last one, I'm going to go the square root of 3.999 minus 2 over 3.999 minus 4. And again, I'm going to go second and enter. And then I'm going to get up to that 9 right there, hit second and delete, type an extra 9. I have 390. You can't see them so well because I split the screen. And then go here, second and delete to enter, and get my third 9. So that's a faster way to type these in. And this gives me 0.25002. So my guess is the left-hand limit is 0.25, which is a quarter. So my answer, because I'm going to do it as a decimal, but when I do the algebra, I'm probably going to get a fraction. So my left-hand limit of this fraction, I think, is 0.25, because each one of these numbers we're getting closer and closer to 0.25. Now I'm going to do the same thing for my next table to get the right-hand limit. So I'm going to go 4.5 minus square root of 4.5 minus 2 over 4.5 minus 4 first. So second and enter. I'm going to delete a couple of these. So I get right on that 3. I'm going delete, 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 and delete, and then second insert 4.5. So there's the 4.5 minus 4, and then over here move to the 3, delete, 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 and then delete, and then second insert 4.5. So there's the 4.5 minus 2 over 4.5 minus 4, and I get 0.2426. I'm just going to write 0.24. For the next one, I'm going to do the square root of 4.1 minus 2 over 4.1 minus 4. So second, enter, and then move to the 0.5s and make them 0.1s. I can type right over those because they're the same length. And I get 0.2484. I'm going to write 2.248 just so you can see the pattern. Then I'm going to do the square root of 4.01 minus 2 over 4.01 minus 4. So second and enter, trace, second, delete, type a 0 in there, so I've got a 0, 1. Move over to the 1 over here, second and delete, type in a 0. So now I've efficiently typed in what I needed to type in, and I get 0.2498. These are going to 0.25. If I started rounding it, I'd have 0.25 the whole time. And then the last one, the square root of 4.001 minus 2 over 4.001 minus 4. This is where the video is going to start cutting out on me. So second, enter, and then move into where the 0 is. Second, insert 0, and then, I just probably messed up. Second, insert 0, I think it's right. And then over here, get onto that 0, second delete or second insert 0, and I get 0.24998, 0.24998, and again, all those are getting closer to 0.25, so I'm going to write that 0.25 for my limit. So I'm going to say for part, the answer to part B is the limit as x approaches 4 from the right-hand side of the square root of x minus 2 over x minus 4 equals 0.25, which is a quarter if you happen to know that. And there's no table for part C. Part C wants me to find a two-sided limit, and because the left-hand limit is 0.25 at 4 and the right-hand limit at 4 is 0.25, the answer to part C is going to be 0.25. Now I want to do algebra to find my limit. I'm going to do that on another sheet of paper. And this is really kind of out of place, a little bit hard. And I'm going to redo this trick in the next section. This is just kind of just to warm us up for the next section. Because in the next section, most of the problems want me to use algebra to find the limit. And there's a handful of tricks. And I just want to expose you to two of the tricks for finding limits. So the first trick for finding a limit is just plugging the number in. So that's what I'm going to do here. I'm going to get the square root of 4 minus 2 over 4 minus 4. That's going to be 2 minus 2 over 0 because the square root of 4 is 2. And that's not good because that's 0 over 0. And that's undefined. But the limit is 0.25, which is a quarter. So sometimes the algebra strategy of just plugging a number in for x isn't enough. And there's a couple other algebra strategies that we have to learn. And the hardest algebra strategy was this one. That's why I wanted to show it to you at first in this section. If you don't get it in this section, it's not that big of a deal. We'll have a handful of problems in the next section that require this trick. So once you get undefined, when you're going to find a limit, but you know the limit exists, then there's some algebra to do to get that limit to come out. And the algebra for this is to multiply the numerator and the denominator by the conjugate of the numerator. The conjugate, it means change the sign. The conjugate of the square root of x minus 2 is the square root of x plus 2. So the algebra way to find the limit broke down when I plugged the 4 in. Doesn't mean the limit doesn't exist. It just means I need more sophisticated algebra. The more sophisticated algebra for this problem is to multiply by the conjugate of the numerator. And I'm going to do my numerator. So in my numerator of this, I'm going to FOIL. So I'm going to go square root of x times the square root of x. So in the numerator, my firsts are going to be the square root of x times the square root of x. That's the square root of x squared, and the square root of x squared is just x. My outers in the numerator are going to be the square root of x times 2, and that's positive 2 square root of x. My inners in the numerator are going to be minus 2 times the square root of x, and that's just minus 2 square root of x. Hopefully you knew I didn't have to do the outers and the inners, that they were going to cancel. And my lasts are minus 2 times 2, which is minus 4. When I'm using this trick of multiplying by the conjugate of the numerator to find the limit, I don't multiply out the denominator. So what's going to happen, these are going to cancel, and I'm going to be left with the limit as x, not L, as x approaches 4. Now the numerator just has an x minus 4 in it. And the denominator has an x minus 4 and a square root of x plus 2 in it. Well, the x minus 4s are identical binomials, so they cancel. So now I can rewrite this problem. The algebra way to find the limit as x approaches 4 of 1 over the square root of x plus 2. Ultimately, the only way I can find a limit is to plug this number in. The problem is, the original version of the problem, if I tried to plug the number in, it didn't give me what the limit is. So I needed to rework the problem by doing legal algebra, and multiplying a fraction by its conjugate over its conjugate is like multiplying the fraction by 1, which changes the way the fraction looks, but it doesn't change what the fraction equals to. So I did the grungy algebra, and now I'm going to plug this number in for x. So I'm going to get 1 over the square root of 4 plus 2. This is a good thing, because this is going to equal 1 over 2 plus 2, which is a quarter. And that is what the limit is. When I did the limits with my table and I got 0.25 for an answer, 0.25 is equal to 1/4. And for my answer to part D, because the algebra gave me the fraction, anytime I can get a fraction, I prefer it to a decimal. But if you gave me 0.25, that would be fine. So that's the table part shouldn't be tricky. The algebra part should be tricky, and doing one of a problem is never something that I'll do if it's going to be test worthy. So in the next section, we're going to get to learn this trick again and again. We'll do 2 or 3 more, but I just wanted to expose you to 2 strategies for finding limits using algebra. The first strategy is to plug the number in. If you get a number that's defined, then that's what the limit is. The second strategy is if you get 0 over 0 and you have a fraction, there has to be a way to rectify that problem so you can plug the number in. Because if you know what the limit is, then you should be able to get that limit to come out. All right, so give problem 19 a try. Hopefully it has a nice-ish limit and you can find it. And then check your answers, and that's the entire first section. So hopefully I haven't scared you off so that you don't want to stick this class out. I'll go through all the problems in hopefully enough detail that you can get through the course, even if your algebra skills aren't stellar. Anytime we need to remember some algebra from college algebra, intermediate algebra, I'll review it in the videos. So hopefully you're not scared off and that you can just get through this. But go ahead and do all the odd problems in section 1.1, check your answers, and then if you're still not falling asleep, you can try to go into section 1.2. All right, I'm going to pause the video or stop it now.